Well, welcome to Lesson 4, Introduction to Solving Equations. This does say introduction, but as you know, we've looked at this in our grade 8 review. So you've seen equations before, but we're starting the second half of the algebra unit. Just going back and trying from first principles, just talking about equations. And that just in case you weren't quite comfortable with them before, and then we'll take off from there. Now, as it says here, that that you're going to have equations for the rest of your math lives, and even in all the different occupations you do, you're going to be looking at equations, and that so they're quite important because problems can be represented by equations, and we want to solve problems, so therefore you want to solve equations, and that so. In just asking, by the way, what makes it an equation, and it is the fact that it's got the equal sign between two expressions, and that here the one side of the expression is just a constant, but you can see over here it's two terms and on either side, and we can always solve if there's a variable that we're solving in it, then we can solve and isolate that variable. So let's take a look then at this first question, number A. Now, I think a good way to first think of equations is looking at a scale or a balance in that, because with scales, whatever you've got on one side has to equal the other if they're going to be balanced. So whatever you add or take away to one side, you got to do the same to the other, or the equality or the balance is gone. So if we look at this, we could kind of show that we've got 7x plus 3 on this side, and we've got 24 on this side. And we're saying because of the equal sign that they are equal, or they balance out. So we could, therefore, kind of look at the equal sign, being here. So whatever we do to one side, we've got to do to the other. And we notice on, we're solving for x. So on the left side, there's 7x and another term, a constant 3. And that, so we'd like to get rid of that 3. And to get rid of it, we can subtract 3. So we can subtract 3 on that side, but we're also going to have to do that on this side to maintain balance, and that. So once we do this quite a bit, we can see that that here these are going to cancel out, and because that's why we did it, so that we would get rid of the 3. So that's why sometimes we talk about if you take that and bring it over, its sign changes, because that's the net result of the operation we did. So you can always be adding the opposite here, but the result is like you brought it over and it's now negative 3 on the other side. Or if this was a negative 3, it would become positive 3. So continue adding the opposite to get rid of it, and when you're comfortable, just bring it over and change the signs. Later, we'll then have 7x is equal to 21, and we don't want 7x, and x is being multiplied by 7, so we're going to have to do the opposite, and we'd have to divide both sides by 7 when we're done in that. So we'll look at that. So the first step is always to get the term with the variable by itself on one side, and then make sure you just have one of it, and that. So that's the steps that we take. So I'll get rid of this picture, and we'll go back to actually working on problem A. So if we do continue with this, then we would, as stated in the run up with the scales here, we would do our 7x plus 3 subtract 3 is equal to 24 subtract 3. Now we want to gather like terms, and we've got this section here where there are like terms, and this is like terms, so we can reduce those. So obviously this is going to result in eliminating it, and that's why we did it. And so we're going to end up with just 7x on this side is equal to 21 when we combine the right side. But again, it said that we don't want 7x, we just want x. So we're going to do the opposite. X is being multiplied by 7, so we're going to now divide by 7, and what you do to one term in the equation, you must do to every term. So we've got, there's only 2 terms in this, one on each side, so we divide the other side by 7. And the reason we divided the left side by 7 is that we could just get x by itself. And 7 goes into 21 3 times. So that is our final answer. We've solved the equation for the variable that's in it. So we've solved for x. All right, so that's A, and let's move on to B. All right, so here's B, and now we notice we have 2 terms with x in it, and we've got 2 other terms that are constants, and we're solving for x. So step 1 is to get terms with x on one side. So let's look at that. We want to do that. Now one way is I could add 4x to both sides. And if I add 4x to both sides, so I could add a positive 4x to both sides, which would negate or eliminate that negative 4x, but I'd have a 4x now over on this side. So we did talk about moving that over, and its sign would change. And the reason we say that is because we're adding a plus 4x to both sides. This would be eliminated, so it's like taking the negative 4x, moving it to the other side, and that's what I'm going to do right now. I'm just going to note that I'm going to bring this term to the other side. So my next line, again, if you want to take that one extra step and put a plus 4x on both sides and then collect like terms, that would be fine. So I'm going to do that, and I'm also going to bring this to the other side, and that because we want just the x terms together. So that's like adding negative 6 to both sides to get rid of the plus 6 on the left-hand side, and that which would result in a negative 6 being on the other. So it's really good to get used to knowing that you're bringing a term over and its sign changes. That's probably the fastest and easiest way to look at these. So as a result, we're going to get 12x plus 4x, the result of bringing the negative 4x over, is equal to 38 take away 6. Now the other thing to note here is that every line in your solution underneath the original equation only has the one equal sign in the middle. Okay? When you're simplifying expressions, which we were doing in lessons 1, 2, and 3, you just have the one equal sign at the beginning because it's saying an expression is equal to the next expression. But when you're dealing with equations, just the one equal sign in the middle. Okay, so the next step is to gather like terms. So now we're going to get 12x and 4x is 16x is equal to, and 38 take away 6 is going to give us 32. But again, I don't want 16x. I just want x. X is being multiplied by 16, so we do the opposite. And whatever we do to one term, we have to do to every term in the equation. So over on the other side, there's just 32. So I divide it by 6, and we get x is equal to 2. Final answer. All right? So that's B. Let's move on to C. All right, now looking at C, just because there's a fraction, a lot of people are just going to panic and forget all the rules that we said. previously. But if you remember what we talked about, it's to get the term with x all by itself. So to do that, and it's okay, it's on the right-hand side. We could put it on the left-hand side, but as long as it's all up by itself on one side. So to do that, let's bring the negative 8 to the other side, which will change its sign, because we want the x term all by itself. So that's going to give us 4 plus 8 is equal to 4/5 x. So don't worry about the fraction that the x is being multiplied by. Just get all the x terms together, if there's more than one, and collect them. And get everything else to the other side and collect them if you can collect like terms. So our next step is collecting the like terms, and we've got our 4 and 8 is 12 is equal to 4/5 x. Now when we were doing the grade 8 review, and some of our other work in lesson 1, 2, and 3, we saw that we could multiply this by the reciprocal, or the opposite fraction. So I could multiply both sides by 5/4 and wipe that 4/5 to once, but that is a big step for a lot of people. So what I suggest doing is multiply all, you got to do it to everything, whatever you do, multiply all terms by 5. So if I were to do that, if I were to take this and multiply it by 5, and take all of this and multiply it by 5, obviously these 5's cancel. That's why we did it. So what I will get is 5 times 12 will be 60 is equal to 4x. So now that looks so much more doable. And we know we don't want 4x, we just want x. So I can now divide both sides by 4. And 4 goes into 60 15 times. So we get 15 is equal to x. And we are done like dinner. That one's done. So not too bad. Let's move on to D. All right, so D. This one is going to panic people because, oh, there's a squared term, and the x term's negative. So we got 3 variables in this, but stop and think about what the original question asked for. And it said to solve for x, not y and not m. So you want to get x by itself. Now, I could get it by itself on the right-hand side, but it's negative. Why don't I move it to the other side? I could do a few things at once. I'm going to want to move the y squared to the other side too, but I think I'll take my time and do one thing at a time here. So if I add mx to both sides, I'll get rid of it on the right, which will result in y squared plus mx is equal to 7. But I want the rule is get the term with x in it all by itself. So don't worry that it's being multiplied by another variable. Get it by itself. So the y squared here shouldn't be on this side. So I've got to move the y squared to the other side, which will cause its sign to change. So that will make it so I've got mx, and it could be negative y squared plus 7 or 7 take away y squared. It doesn't matter. I'll put the y squared first. It's going to be negative plus 7. Now again, in the previous question when we had 4x, we didn't want 4x. We just wanted x, so we divided by 4. Well, it's the same thing. We got mx, so it's m times x. We have to undo that. So what I have to do is divide that term by m. But if you do that, you have to do that to every term to keep the balance, to maintain equality. So I got to divide that by m, and I got to divide that by m. So I know it's a strange looking equation, but we have solved for x because now the m's cancel on the left, and I get x is equal to negative y squared over m plus 7 over m. Now, depending on how you did this, you might have had x is equal to 7 take away y squared, and you might have had that all over m. That's really the same thing. So that's okay too. Or you might have had x is equal to 7m take away y squared over m. That's the exact same thing. As is, if I did what we just have in blue, but it's all over m. Those 4 solutions are really all the same thing, so they'd all be acceptable. And but that was the one I came up with, but the ones on the right are fine. So that's it. We're done the intro to 1.4. Make sure you've got this all on your blue booklet.